Hi, Jerry Christopherson here again. Today I want to talk about something that everybody knows about, I'm sure. Everybody knows what a PMGR is, right? Everybody knows what that is, right? Permanent magnet gear reduction starters. Ford came out with these small starters in about 1992 and put them on all their small block engines. And what I want to do is show you how to put this starter on, which is a far better starter than the direct drive starters that came with the early 60s Mustangs, Tigers, Fords. We can put these newer style starters on there because they are lighter weight, they're more powerful, much smaller, and draw less current. So all four of those are all pluses. Why you'd want to put this starter on there. Now what can be a little more challenging with it is how to wire this thing, and that's basically what this video is about, is how to wire this thing. There's about 4 different ways, there may be more, but I've got about 4 ways that you can wire this thing up in your car, depends on how you want to do it. It's up to you. But I'll show about 4 different ways on how to wire this thing up. It's real simple. There's nothing hard about wiring it, but anyway, that's what I'm going to talk about. And I'm going to go down to my little rotating table with some starters on. I'll show you the differences in these starters. There's 2 basic differences, and that is one for an automatic transmission and one for a standard shift transmission. But you'll be surprised that sometimes, even though you have a standard transmission, you may want to have an automatic starter. And I'll explain why that is down here on my rotating table here. I got the starters down here. Trying to hold these starters up here and trying to show a difference is a little bit too hard. So anyway, we'll go down to my turntable, and then after I'm done there, I'll come back up here and get into the wiring diagram. Thank you. Okay, here's the 3 types of starters I want to talk about. You're all familiar with this one. This is the one that's on all the engines, all the motors, all the engines I should say. And you're all familiar with this thing. It weighs almost 18 pounds. And these are the ones that have the gear reduction in them. They're considerably lighter. This thing's almost 18 pounds, 17, 18 pounds. This one's just under 8 pounds. So it's a lot less weight, more power, draws less current, and they're smaller. For us Tiger owners, that's really nice because you can get your headers in and out of the car where you can't do it with this one. But this one is small enough you can get it into the engine and not take your headers out. That's a very big plus. Now, I'm going to take this away because it's just a big, heavy boat anchor as far as I'm concerned. But I want to talk about the difference between these 2 starters. If you can see, let's see if we get this lined up, you'll see that the gear here, the Bendix gear, it sticks out farther on this one. It's called a long nose. And this is the short nose. But what they have done is everything in the motor and the solenoid and all the stuff, the shaft, the motor, everything inside this thing is exactly the same, except this casting here is a little bit, they have cast this flange farther out. Okay? See the difference here? This difference in there? This flange has been cast farther out to make this thing appear to be shorter. It doesn't appear to be, it actually is shorter, it doesn't stick out as far as else referred to as the long nose and the short nose. Now, why did they do that? The reason they did that is because of different flywheels and flex plates, automatic flex plates. Now, which one goes to which car? Depends on which flywheel you have. If you have the bigger, like in my Tiger, I have a 164 tooth flywheel in there. For reasons I don't really remember why I did that. I wish I'd have got the smaller one, but that's what I have. I use this one here because this one, the teeth on the flywheel are closer to the engine. Okay? So this thing has to sit back farther before it engages the teeth, which will ride right, the teeth of the flywheel ride right there. Now on 157 tooth and the 160 tooth and the flex plate, it's an automatic, some of you have flex plates, the teeth on that flex plate sit farther towards the transmission. So those teeth ride out here farther. So this thing has to be, it's about 3/8 of an inch difference in this. If you put this into this, requires this, the thing will just sit there and spin. It won't happen. If you put this into what this is, the teeth will stay engaged in the ring gear all the time, and you'll tear up the starter. So you don't want to, make sure you want the, whatever starter you take out, like this big one, you can look at it. If it looks like this, put that kind back in. Okay, it all has to do with the flywheel, and I'll try to draw that on the board there to show you a little difference where those teeth are on the flywheel themselves. Okay. Now I had this grand idea of taking this motor apart and show you how to take it apart and clean it and all kind of stuff, but it really, these motors are so cheap that just go down and get one at a junkyard, clean it up if you like. If you do want to take the thing apart, it's not difficult. 2 bolts over here on the outside, 8 or 9 millimeter, I can't remember what they are, and this thing all comes apart here. But you first want to take this nut off here, and there's 2 Torx, number 25 Torx bolts there. Take those out, take the solenoid out, then these two, and this thing comes right apart. But the one thing you gotta watch out for, between the armature and this shaft here, there's a ball bearing in there that rides like this here. And it's a bearing surface, but it's just one ball bearing, and it's free in there. But when you take this apart, don't lose that ball bearing. It's a 1/4 inch diameter, or whatever millimeter it is, ball bearing. And I'm letting you know that's there, and when you take it apart, you know where it goes. It goes right into the center of this shaft in the back here, where the 3 planetary gears ride on there. Something that's interesting in here that I thought was interesting, the ring gear around here with the planetaries ride around in, it's all plastic. some kind of plastic. It's just crazy that, as much power this thing puts out, that plastic is good enough. Also, there's this plunger that's inside this solenoid here, pulls a little thing that pivots right here, and moves like this here, which moves that Bendix out in. When you energize this thing, it pulls this down. Well, that little teeter-totter thing is also made out of plastic, but apparently they work a long time. There's one other little thing that you might run into, and that's the difference between where this thing fits into the engine plate, right here. One of them is about 5 thousandths of an inch bigger, and I think it's the automatic one that's a little bit smaller, but this difference doesn't run into effect unless you're trying to put the bigger one into the smaller hole, which I ran into that one time. But what I did, instead of taking the whole engine apart and get the engine plate out and I just took a flat file, bastard file, and I just filed around on this edge, all the way around here, enough. It's only 5 thousandths of an inch, so I just ground that down, and it fit in there just fine, no problem. I don't know if you'll run into that problem, but I'm just saying that you could run into that problem if you, depends on what engine plates you have and what engine combinations you have and all kinds of stuff. But don't let that stop you from putting one of these motors in there, because they're far better motor, lighter too. Okay, I want to talk about, I'm going to draw on the board up here. I'm going to draw a circle which represents this motor here. I'm not that good of a drawer, so that's why I want to explain this. I'm going to draw a circle here and a circle up here. And the big circle will represent the motor, and the one up here, the smaller one, will represent this starter solenoid. Now there's a couple different kinds of connections. Now this is your main battery, comes to this one. Your main big battery, big cable comes to this thing. This is where the big power goes through when you close the solenoid. This is when you turn the switch on, that you energize this thing, which energizes the solenoid and closes it. Solenoid does 2 things. It pulls the Bendix out like this with the little teeter-totter thing I was just telling you about, and comes back and closes a big switch back here. So the current goes from here to there, to the motor, to the ground, which spins the motor. But one of these, like here's a good example. Here's one where it's just a blade you hook up here, and this wire that goes there can be a 12 gauge or something like that, or smaller. It doesn't draw a lot of current really, but here's one that's actually a little bolt on it. So you'll run into either kind, depending on the motor, what it was on initially. But that's the basic difference between these 2 starter motors, and you want to be careful that you got the right one. And I think I explained it well enough. It's just whatever you take out of the, like for instance, this bolt on here, You can see that thing, how far that thing closes in. Well, obviously you would want to get one that's just like that, like this one. You wouldn't want to do this one when you pull one out that's like this, okay? So that's you know. Okay, I'll go back to the board and talk about some things. I'll talk about that the ring gear on a flywheel, what that looks like, and so you'll know when you look inside there, you'll know which one to get. That'll help you also. Okay. All right. Here's my depiction of flywheels to show you the differences in those two flywheels. Three actually. But anyway, the bigger flywheels, the teeth are closer to the engine's down here. The engine here, transmission up here. Well, better do it. E-N-G here, down here. That's how they're in the car. The 164 tooth flywheel, the teeth are closer to the engine, requiring a shorter nose starter. Okay. Now on the 157 tooth and the 160 tooth, which the Tiger owns, the Tiger 260 engine has a 160 tooth flywheel. They're both the same in this regard. Those teeth, these represents the teeth, and that's the flywheel here, bolted to the engine. Starter needs a longer nose on it to be able to engage those things. So you can see if you had a longer nose and put it into a 164 tooth, those teeth would already be engaged in that thing, and that's why you will tear up a starter if you put the wrong starter in. The other way, it'll just spin and nothing will happen. It may catch a little bit, but make sure you long nose, short nose, which one goes where. But that's how the flywheels are set up this way, and they went this way on the bigger ones, the Bosses and other. I'm not sure what all engines they went to on this, but so they could have more room in here with their pressure plate, or it had something to do with that, which I'm not really sure what it was. But anyway, that's what it looks like. 157 tooth, the flywheel and or the flex plate will be like this, where the teeth are farther away from the engine, needing a longer snout. 164 tooth needs a shorter because the teeth are closest to the engine. Okay? All right. And there'll be four options. Some of them you like and some of them you don't like, but there are options that you can use to hook these starters up. This option here is like an original car would be hooked up, that has this starter motor on, like a Mustang or Ford, whatever. Excuse me. And it would be a good way to hook one up. It's very easy, simple to do. You just take the wire that goes from your battery up to your solenoid, the original Ford solenoid that sits on the side. I'm talking about early cars like Mustangs and Fords like this, 64, 5, 6, 7, 8, and 9, something like this. They have a solenoid up here on the fender wall that goes down. So what you do, instead of having this solenoid in the picture, you take the red wire from the positive wire from the battery. Instead of going to here on your solenoid, you put that thing over here on the top of this solenoid. Okay. And also the wires that go to this thing, that go to the rest of your car functions, lights, headlights, fans, anything in this operated by 12 volts is usually hooked up to here. Take those wires and hook it to this one also. So now all the power that the car uses, this electrical, whatever they are, lights, powers, fans, this is where it gets the power off, because it's all you're moving is these wires from this nut here over to here, and the power goes to there. Nothing has really changed about where it goes. It's just you've taken this thing out of the picture for now. That will work just fine. Now some of you say, well, there's a if you're running points and stuff like this terminal right here, goes to your ignition system on older cars and bypasses the little resistor, your resistor that gives you 6 to 8 volts to your ignition, except when you first use this start, this thing closes here and power goes from here to here down to your starter. Okay? But it also energizes this thing and goes to your ignition system and gives you 12 volts just on your initial startup. Gets you a little hotter spark on when you are starting. When you go to run, this goes cold and this also goes cold. Okay? Now you might say, well, I need that to get this thing to run here or something like this. If you got electronic ignition electronics like this, I'm not so sure you need that extra 12 volts to do it. But here again, this is something for you to decide whether you want to do it that way or not, or whether it gives you some kind of problem. But anyway, this is what I'm going to call number one. A good, easy way to do it. This is a switch. This is your start switch here. When you close the switch, you bring power to this solenoid, closes that solenoid, closes the switch here, gives you power from there down to here. Where this thing goes right down to the motor and then goes through the motor, through the brushes, down to ground. That's how you get power to the motor. Okay. Now this is number. I'm going to call this number one. Okay. Now we'll look at number two. Now here's number two. Number two is a way of hooking up that I really don't advise. You might think it will work here, but I'll show you why it's not a very good reason. And that is, you can run two solenoids, two relays, two solenoids is what I mean there. This solenoid and that solenoid. And that will work just fine. There's nothing wrong with turning on both solenoids at the same time. They last a long time, and it's, you know, somebody may think, well, you know, if you got two solenoids, you got twice as much chance of it quitting. I run a similar system to this. I'll show you what I do later, but I run two solenoids, and it's been in there for 13 years. So that's not necessarily a problem. Okay, but here's what, if you hook it up this way, like I say, it'll work and all. And what happens, power comes to the battery, like your normal solenoid that you have on Fords and Tigers. And the power goes down to your original starter. Well, you just take that off, put it onto this new starter and up here, and so far that's good. Okay, then you run on your two little bolts attachments that come out here. One is ignition and one start. So you got an I and an S on there. Ignition is when you close the ignition toward the start, and current comes up here and closes this big switch. This solenoid is nothing more than a big relay that can make big contacts and that can have a lot of load go across there, a lot of amps go through this thing. Okay, and what this switch does here, when you power that with 12 volts, it closes that thing, so this one and this one are now connected, so power will come down to here. This one is called, got an S on it, for start, and the reason they do this is they have this thing hooked up to your ignition system so that when you first start, 12 volts is going down here to the other side of your resistor, your distributor side of the resistor, and will give you 12 volts to your distributor when you initial start. When you have points in there, this is what helps with points. It gives a little more voltage in there to help start the car. Now when you open this circuit here, this thing opens up, cuts off the electricity going from here down to here, but you have some electricity coming back because in the run position here, the electricity is coming down and going through the resistor and going through the distributor. So now that's about 6 or 8 volts, depending on what kind of resistor you have. That 6 or 8 volts comes back up here and will go down to this line, which you think you could normally hook up to the solenoid right here to energize the solenoid. But you get the 6 and 8 volts going back to this thing, and it can make that thing hang up. And so this is not a good way to do it. But some people may say, well, I can just hook this thing up here and then put this one over here, and when this thing goes hot, this goes hot also. They both go hot independently. Well, they both go hot when you close the solenoid, and which will give you 12 volts there, which will start that thing just fine. But now when you come back again and turn it off, this thing opens up, but you still have this little 6, 8 volts, depending on what it is, going up to this solenoid, and that may pull enough current there that it takes away from your distributor. So you don't want to do that. So do not hook it up this way. I'm just not in favor of this way at all. But now we'll go to number 3 and see what that looks like. Okay, here we have number 3. Another one that's can be used. I don't highly recommend it for a reason I'll tell you. But what we do here is we retain our solenoid. We're going to run 2 solenoids again. But in this case, we run the solenoid out here. Well, because when this thing goes hot, when you close the switch, solenoid collapses, current goes from here over to here. Now, if you just run a wire from the activating point here up to here, you will energize this at the same time you got current there, and that will work. You might think this is a great way too, and this actually works a lot better than the last way, because now you retain this 12 volt that you want to go to ignition, if in fact you want that. When you go to the newer ignition systems, and like mine, I have the DuraSpark 2 system and an MSD, and I don't use this thing at all. There's no reason whatsoever to use it for any reason, because there's no reason for it. But what happens here? There's something that happens here, and it's kind of interesting. When this motor is spinning, it's spinning inside of magnets, permanent magnet motor. It's got a bunch of 4 big magnets on it. When everything is spinning in there, electricity is making it spin, but also when you turn the electricity off, it's spinning a little bit, but it kind of creates its own current. And that current can come back out of this thing and energize this thing. And what it does, it makes the starter run on a little bit. It stays engaged after you turn the key off. It stays engaged a little bit, and so you get this little run on. It keeps running. It eventually stops because it doesn't produce enough current to run itself. It's not perpetual motion. But so you get that little run on. If that really bothers you, we'll go to another way of doing it. But this would work, and I think I'm not so sure that my alternator generator guy said it may shorten the life of the starter a little bit if you do it this way, because of this run-on problem. So this. What I'm saying is you may see this as another way of hooking up, but it's really not the best way. It'll work, like the other ones will work too, but not necessarily the best way. Let's see a better way of doing this. Okay, this is number 4. This is really the preferred method. It's easy to do, and you don't have any problem with this starter here. You can still run your 12 volts off of this thing if you need to. If you have electronic stuff, you really don't need that. But anyway, what you do here, and all these heavy lines are battery cables. Now the Tiger comes with a number 4 cable that goes all the way from the back of the trunk and up there. I would suggest running a number 2 rather. It's a little bigger cable, and you get a lot more current to your starter. If you got a battery that's a little bit weak, it'll still pull that thing. I had a chance where I could see the difference. I had a battery that was getting kind of low, and I'd go start and go, it would start. And I went to a number 2 cable, went down to, got a welding cable, 15 feet of it, whatever it was, and put it on there. And same battery, same engine, same. The thing would take right off. Wow, what a difference between 4 and 2. Big difference. But if you're dealing with a concours car, you can stay with number 4. It's just your battery needs to be pretty well up all the time. Anyway, this is how a real good way of doing it is just take another lead, a heavy lead, number 2 or 4, go from your positive side of where your battery's hooked up to your original solenoid, go from that side all the way down to the top here of this solenoid. Okay, like I say, number 2, number 4. Down here, you're going to go from this side here now. The only wire that's going to be hooked up there is a small wire, like the number 12. It goes from here down to the solenoid. Because when this thing closes, when you close the switch, this energizes this solenoid, closes. You get you'll always have 12 volts to here, whether this is open or not, right? That doesn't change. But what you do, you're closing this big switch, making a big switch to operate this thing in here. Now, what happens when you open this thing, that thing goes cold. So there's no current going anywhere when this thing, you don't have any run on or anything like that. So this kind of system really is the best one that I would recommend. Now, for somebody that, you know, people are concerned about the switch, whether the current, enough current, too much current is going through there or something like that. If you feel that way, right in here, prior to this start here, put a relay right in there. Put a relay right there. And then power up so that the relay will handle a heavier load to this thing. I don't really think you need it. I know some guys will do it. But, so anyway, this is probably the preferred method other than the initial one, number one. So, but here again, it's just very simple. Power comes up and it's over here. It's constant. It'll be constant hot here, just like this is constant hot. You just have a big cable going there, constant hot. When you hit the switch, you close this. You're causing power to go to this one. This down here, not the start one down here. This is I and S. Remember, this is our start. This goes to your ignition system. Remember on number 3, this goes to ignition system. It's a small. This you hook that wire up to this big lug right there, and go down here to this lug here. And that when that goes hot, boom, the engine starts. Well, guys, that's about it. I'm not. There's probably some other ways of hooking this up. I'm not sure, but here's some ways that you should hook it up, and some ways you maybe not should hook it up to make sure that it runs. It's very easy to do. You can go back and look at each one of these things and see which one you like. This one is my preference. I don't. I actually mine on my Tiger. I think I have number 3 where I have this thing is hooked up to this thing because I don't use this thing for any other reason than to fire this thing. I don't have ignition hooked up there because I have a electronic ignition, so I don't use that. So when these two go dead, it goes dead. So I don't have any problem with that current coming back up to it from your ignition. So, but anyway, all right, guys. I hope this hasn't got too long, but anyway, I appreciate you watching. I hope this helps somebody because it's a much better motor. Starting motor for much lighter, better deal. All right.